Welcome to another edition of RCE. Again, this is Brock Palin. You can find us online at rce-cast.com. There you can find links to our Twitters, our blogs, and all the back catalog of over 100 episodes on scientific computing. I've again here Jeff Squires from Cisco Systems and one of the authors of OpenMPI. Jeff, thanks again for your time.
Hey, Brock. So we are recording here just about on the eve of the eclipse. I think this episode will probably be published after that. So everybody will have seen super exciting totalities, including me and including our guest today.
Yeah, in an office full of tech people, you can only guess that around half of our office is taking that day off to go do something related to the eclipse. So
yeah, it's actually an excused absence at my kid's school. So we just have to say we're going to the eclipse, and that's good enough.
That's actually not a bad idea. It's like the one time to be able to see it. And now where you are, it's much closer to where you are than where I am up here in Michigan.
Yeah. We just drive 2 hours south, and it's right here in Bowling Green, Kentucky. So we're just going to drive down on the highway, pull off on some country road style, and like picnic style spread out and bask in the glory of the totality.
So we have with us the CTO from PBS Works at Altair. You want to go ahead and give us an introduction?
Hi, this is Bill Nitzberg. Really happy to be here with you guys. I got my start actually back at NASA where we developed the PBS Pro software. Now I'm the CTO for PBS Works at Altair.
So can you give us a quick rundown of what is PBS Pro?
Sure. PBS Pro is software. It's funny. I always end up at these conferences where I can't tell whether someone's selling software, hardware, or services. So I always start with that. It's software, it's middleware, so it's operating system level middleware that does job scheduling and workload management. If you're an HPC, I don't have to say anymore. If you're not an HPC, probably should say a little more. Do you want to be an HPC today?
Yeah, you said one little phrase there. Let me ask you, you said it's operating system level middleware. What do you mean by that phrase?
So I sort of think of software as three layers. So there's the hardware. People know what that is. You go buy it. There's the operating system. Everybody knows what those are, hopefully. And then there's applications that you use, like Gmail or like some computational fluid dynamics application that's blowing air over airplane wings. And then in between all of that stuff, in between the applications and the operating system, is this stuff called middleware. And it does the extra stuff that the operating system doesn't do.
Okay, so then what is PBS Pro's relation to that? You said it's middleware. Let's pretend we're not an HPC today so that we give our non-HPC friends a little overview here.
Okay, awesome. So PBS Pro is software that you use on large HPC systems, so clusters or clouds where you're connecting together lots of different nodes together, lots of different computers together. And the simple version is that it sort of does traffic control, scheduling. So what happens in high-performance computing is a lot of the work is super computationally intensive, so it uses a lot of compute power, and it ends up being cut up into little pieces and handed off into the system in what I would call jobs. And then there's also a lot of people, say, competing for that resource, and so there's a lot of jobs from a lot of people. And PBS Pro does the traffic control, the scheduling, the watching of the system to make sure it's still running. Does that make sense?
Yeah, it does, but clarifies something. This doesn't serve a role in terms of your programming API, right? This is managing the resources, but not serving a role like MPI or CoArray or something like that, right?
That's right. So we take effectively prepackaged, what a job is to us is sort of a prepackaged thing that you might run on your own from the command line. So you might run, say, some structural optimization code. Say you ran optstruct to, test the flexibility of your cell phone display or something. And you could run that from the command line. You'd say, blah, 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 optstruct, blah, blah, blah. And it would virtually crash test your cell phone into some cement. But it might take 3 or 4 hours. And you might not want to just drop it once virtually. You might want to drop it from a lot of different angles and a lot of different heights. And so that ends up being, say, 1,000 different jobs that you might want to run. And so instead of running those 1,000 different jobs by hand one at a time, what you would do is you would package them up into jobs, and you would submit them to PBS. So PBS is not the API layer. It's really at the application layer. And it's very agnostic to application. So I just used OptiStruct as an example, but it's anything that you could run basically on an HPC system.
Okay, now PBS in itself has a long history, and you even referred to it in the beginning back there. Give us a little bit about the history and the evolution of where this came from.
Actually, there was a system back in the very early super mainframe computer days, in the sort of the Cray days, called NQS. I think it stood for Network Queuing System. And the group at NASA Ames, even before my time, created NQS. And as parallel computers were sort of looming on the horizon, the folks who were developing NQS, I believe, ran out of space in some internal data structure and realized it was time to actually start from scratch. So this was back in 1991, I think. And they actually started a POSIX standards effort to standardize what batch computing looked like. And out of that came a POSIX batch standard for batch computing, but also came a reference implementation, which became PBS, and then became commercial PBS, and now is open source PBS.
Okay, so scheduling seems relatively straightforward. I have resources, I lay stuff out. That's a very naive look at it. What makes scheduling difficult?
That's a great question. I think if you're just looking at your own problem, so if you're, say, one organization and you just have one set of users who are competing for one machine, scheduling actually isn't that hard. And a lot of people actually continue to sort of build their own scheduling system, or even just do something simple and yell over the partitions and say, hey, it's my turn. Do you mind if I run some big job? What makes it hard is once you go from sort of a group of people who can yell over partitions to people who are all coming in remotely, or you go from, say, a few hundred jobs a week to a few thousand, or you go from a few tens of machines to a few 100,000 machines. Just the combinatorial explosion makes it hard. And then HPC is full of really strange and unique things like, nodes without disks, or nodes with Xeon Phi or GPGPUs, or networks that have a topology that you might want to map something to because you get better performance if you have a better mapping. And all of that plays into scheduling.
Okay, so that was a good history, but what about Torque? Wasn't Torque one of the open source derivatives of this somewhere along the line as well?
Yes, it was. Actually, here's the whole the family tree was first it started out as the portable batch system, which got abbreviated PBS. In 2000, actually, I and the group of original developers left NASA to form a commercial company around PBS, and we coined PBS Pro at that point, and also OpenPBS. A few years later, a fork of OpenPBS became Torque. I think Torque is still alive. I'm actually still bumping into it, so Torque is still alive. OpenPBS kind of died. We kept going with PBS Pro. Our group was acquired by Altair in 2003. And then just last year at International Supercomputing, we dual licensed PBS Pro, so that now PBS Pro there's an open source version and then there's a commercial version.
Oh, and what are the differences between the two?
Our goal is actually to try to eliminate as much as possible the technical differences between PBS Pro and PBS Pro. In fact, we decided to choose the same name instead of resurrecting the OpenPBS name because our strategy is to try to kind of bring the two worlds together that have formed around some using open source workload management job schedulers and some using commercial workload management job schedulers. And we really wanted to try to bring those two worlds together. Obviously we have a commercial version, and so how we differentiate on them is that the commercial version kind of like, I guess the way to think about it is more along the lines of, say, the way Red Hat does, say, Fedora and Red Hat Enterprise Linux, right? So you get all the features exist in both, although actually you get